Hello, I am Ahmet Duyar, and I am very pleased to have this opportunity to tell you about our product, AnomAlert, as well as the technology behind it. Let me first introduce myself. As I mentioned, my name is Ahmet Duyar again. I worked as a professor and chairman of mechanical engineering at Florida Atlantic University. During that time, my research area was so-called model-based fault detection and diagnostics, and my research work was funded by NASA Lewis Research Center, by U.S. Army, by the state of Florida. Our technology that we developed initially implemented to the space shuttle main engine, helicopter engines, and gas turbines in the United States. I also received Governor's Award for outstanding contribution to science and technology. AnomAlert is a product which provides early warning of developing faults months before the equipment failure. Unlike some other condition monitoring equipment, AnomAlert is a gives comprehensive coverage for both electrical, mechanical, as well as process fault. It's easy to use, easy to install, and easy to commission. AnomAlert is applicable to critical, complicated equipment, as well as medium criticality and low criticality equipment. For low criticality and medium criticality equipment, it may be the only product or equipment or system that you may need because it provides you the maintenance scheduling and planning information by providing advance notice months earlier. For critical and complicated equipment, it may provide maintenance scheduling information, but at several cases, the diagnostics may be more difficult and it may require additional equipment like vibration as well as some other condition monitoring equipment to determine the cause of the problem, in other words, to diagnose the problem. In those situations, AnomAlert is excellent for providing you the capability of doing condition monitoring when needed. Consequently, both for low criticality, medium criticality, as well as high criticality equipment, it eliminates the significant tedious measurement work that you may be needing, therefore helps improve the effectiveness of the maintenance team. As I mentioned earlier, AnomAlert, the technology behind it, basically uses the model-based fault detection and diagnostics. What is model-based fault detection and diagnostics? Model-based fault detection and diagnostics basically compares expectations with actually what happens. Our expertise is obtaining a mathematical model of an unknown system. This is what we did with the space shuttle main engine. This is what we did with the helicopter engines, T700 turboshaft engine. This is what we did with the gas turbines. We measured only the output parameters and the input parameters. In a sense, we obtain a dynamic correlation between the output and the input. While we are doing this modeling, we effectively obtain the parameters which do not change in time. For example, with an electrical motor, the parameters like resistances, inductances would not change even though inputs like voltages and currents change. Hence, if you obtain those parameters which do not change, they are similar to identification or identity card of the system that we are monitoring. If those parameters change, we associate them with the developing faults. And then further analysis of The difference between the outputs and inputs provides us additional information for guidance. Our expertise, as I mentioned earlier, is in this modeling. With the Space Shuttle main engine, for example, our modeling error is less than 2%. Space Shuttle main engine is one of the most sophisticated equipment, if not the most sophisticated in the world. Since we have such a low modeling error, we can manage to detect the faults that are happening. If your modeling error is not small, then the effect of faults may be lost in the modeling error. With the Space Shuttle main engine, it is about 2%, as I mentioned. With electrical motors or electrical motor-driven machinery, our modeling error is in general less than 0.5%. Hence, that also gives us a significant opportunity for detecting faults earlier. We use system identification algorithms and the concepts in developing those parameters. Hence, our technology and the algorithms included in our product are very, very sophisticated. Even though we have one of the most sophisticated algorithms and the technology, we know from the market study we did in the United States that the users, the end users, are interested in obtaining information rather than complicated and sophisticated data to analyze. Hence, what we did is we converted that data into usable information for maintenance scheduling rather than data to analyze. Our approach allows the AnomAlert system to provide concise information to answer the following key questions. What's wrong? What do I have to do? How soon do I have to do? Hence, we also give an indication to time to failure, as well as we provide action items, suggested action items for the maintenance or for the maintenance team. Again, based on the information we received from the end users, we managed to make sure that AnomAlert has easy to install, easy to commission, and easy to use capabilities. AnomAlerts are typically installed in controlled cabinets. They can also be fitted in separate cabinets for challenging applications. They use simple current transformers as sensors. Hence, as you see in the attached slide, the installation is relatively simple. Its installation is simple, as well as its training process is simple. AnomAlert has a learn period. It learns the system that it's monitoring for about 10 days. This learn process provides AnomAlert to evaluate the parameters during the operation, under normal operation, under the variable and unknown load conditions. And since we have a 10-day that covers a minimum of 1 week period, more than 1 week period, in which time we would see several possible different changes, like load changes, like changes in the supply voltage before and after the peak hours, in the evening, during the weekend. Hence, that 10-day period provides different possible operating conditions that exist with the system. After we learn it for 10 days, the first thing we do is we provide immediately information about the existing faults, if any. Hence, immediately after learn, you will have the opportunity to see what existing anomalies or faults that the system may have, and also time to failure information. How much time you have in order to do the needed action to eliminate that problem. You can go and check to see what AnomAlert says and verify it, and then you can schedule maintenance at a convenient time for you. After the learn period, AnomAlert checks the system almost every 1.5 minutes to see whether the parameters that it has learned during the learn mode are within the expected standard, within the expected range. If they exceed the expected range, which is about 8 standard deviation, then it will start watching it more closely. AnomAlert does not give an alarm immediately. It waits between half an hour to 5 hours before issuing an alarm. We do this in order to minimize false alarms that may be associated with condition monitoring systems. So, AnomAlert waits, as I mentioned, between half an hour to 5 hours, and then in a window, it needs to see at least 80% of the times or more, those alarms are given. When it is sure that those alarms are persistent and continuous, then it gives an alarm. There are 5 different types of alarms that AnomAlert gives. One of them is actually if everything is normal, it gives OK. And if there are changes in the supply line, which are different than it observed during the 10 days of operation, it gives watch line alarm. If it sees changes in the process, like load changes, or if it sees that there are changes in the process, it provides watch load alarm. Watch load alarm is usually associated with changes in the load. This can be done deliberately because the process needs that change in the load, or it could be due to a problem in the process, like a leakage in a pump, or like a tension in the assembly line is getting loose, or filters getting dirty. These we call process faults. And actually more than 54% of the time, when there is a watch load signal appears, it is due to a change in the process, an undesirable change in the process, like a filter getting dirty or like a leakage in a pump seal. When this alarm is given, the operator is expected to note this and determine to see if they deliberately change the process. If they deliberately change the process, then the operator or the user can provide this information by simply pushing a button on AnomAlert and saying that this is normal. So learn this also as part of the process. If it is not something done deliberately by the operator or by the user, then whatever the process fault is can be noticed and the problem associated with it will be remedied. As again indicated, as I indicated earlier, we received a lot of information from the end users before we designed and developed AnomAlert. One of the most important demand coming from industry was to have a product which is simple to use, which is easy to install and easy to commission, as well as a technology or product which provides information rather than data to analyze. So when we developed the information that is provided by AnomAlert, we decided to give, first of all, what's wrong and possibly what the cause of it is, and how long it takes, how long the maintenance people have time. So those are the basic information we provided. In addition to that, there are physical information about the system that we provide. Hence, as you see in this slide 2, rather than a lot of data to analyze, we just simply provide information. Another important feature of AnomAlert the technology actually is developed using the concept of using the motor as a sensor. Hence, AnomAlert detects the faults associated with the driving system or the driven system. For example, in the case of a generator, we can detect the faults that exist in the generator, in the turbine. If there's an unbalance in the turbine, that unbalance in the turbine will affect the generator, and we will be able to detect that. Similarly, in a pump, or especially in fans, if there are unbalance in the fan blades or in the pulleys, in the belts, if there are problems, we find that. These are mechanical problems, and we can observe them. It's interesting to mention that with AnomAlert, we only measure voltages and currents. These are electrical parameters. We measure voltages and current waves, voltage and current waves, and we take 2,500 data every second. But these are electrical parameters. And we obtain and observe the mechanical faults as well as electrical faults. The observation of the mechanical faults, the concept it comes from the following. Whenever you have an unbalance, for example, in the driver-driven system, then that unbalance will affect the rotor of the motor. There is an air gap between the rotor and the stator of an electrical motor. Hence, the unbalance will exert a force, and the symmetricity of the air gap is distorted. This distortion could be in microns level, in very, very small distortions, but those distortions affect the electrical parameters like inductance. Hence, the inductance parameter changes. Since we have the capability of detecting changes in the parameters, we have one of the best algorithms in detecting those changes using system identification techniques that we have developed, that we have introduced into the literature. We have the capability of detecting those changes in the inductance parameter. Hence, a mechanical fault presents itself as a change in the inductance parameter, and we could detect that. So, we use, in this concept, we use the motor as a sensor to detect the faults associated with driving or the driven equipment, as well as the faults that are happening with the electrical motor, like bearing faults, stator faults, rotor faults. So, the concept, again, lies in the following. There is an air gap in the motor, and normally it is expected to be symmetric, and it's a very, very small air gap. A mechanical fault, such as unbalance, would change the symmetricity of this air gap. It will introduce distortion in that symmetricity. That distortion will affect the inductance parameters. Hence, we have the capability of detecting extremely small changes in those parameters, and consequently, we have the capability of detecting some of those mechanical faults as well. This model-based fault detection concept may be further actually analyzed in this slide a little bit better. What we have here can be explained a little bit more. We have the so-called cause-effect relationship. In other words, we measure not only the output but also the input in order to detect a fault. If we were to measure only the current, a change in the current could be due to a fault that's happening within the motor or in the driving or driven system, or it could have been simply due to the noise that the input voltage had. Hence, it would be very difficult to differentiate between them if you don't use model-based approach. In model-based approach, any noise within the voltage, for example, would create similar noise in the current. But since we use the numerical value of the voltage in our model too, hence our current output should include the same noise too. So when we take the difference between the actual current waves and the calculated current waves, since both of them have the effect of noise, they would cancel each other. And the only thing that remains in the difference between the calculated current and the actual current are the actual abnormalities generated by the electric motor. So when we look at the difference, we should only see the effect of the abnormalities that are generated by the motor. We eliminate the noise, external noise, totally. Hence, not only external noise, we also eliminate the line frequency peak if we look at the spectrum of the difference between the actual current and the calculated current. The difference between the actual current and calculated current includes only abnormalities generated by the electric motor, and we make similar analyses like we do in vibration in order to use that spectral information for diagnostic purposes. What kind of equipment we can use this for? As I mentioned, all three-phase electric motor-driven equipment like pumps, fans, compressors, conveyors, as well as generators and alternator systems may be used with AnomAlert. The faults covered with AnomAlert includes mechanical faults, process faults, electrical faults, as well as we provide information about the energy usage. This would be very important because when we look at the Department of Energy reports, we see that equipment faults are affecting the energy efficiency of the equipment being used. For example, if you have a loose belt, the energy loss due to this loose belt could be as much as 5% of the energy usage. Hence, changing an electric motor with a more efficient one, if the motor is about 100 kilowatt, would make a change of 1 to 2% in the efficiency. But just simply, the fan belt would be increasing your efficiency more than around 5% or more than 1.5% if there is a problem. So when you eliminate faulty operation of an equipment, you are also making savings in your energy as well. The equipment AnomAlert, as once again I should stress the fact that provides information, comprehensive coverage of faults, not only mechanical and electrical faults, but also faults associated with the operation of the equipment or the process. For example, dirty filters are observed with the AnomAlert and the unmet condition monitoring systems, which also detects dirty filters or leakage in the pumps. The fault detection and diagnostics are provided on the screen to the user in a very user-friendly form. We provide information in 3 different areas. We look at the power spectral density of the difference between calculated current waves and the actual current waves. This provides us both fault detection as well as diagnostic information. we look at the parameters of the system, electrical parameters. Those changes also indicate about the faults of the system. As well as the third item is we look at the differences between the actual currents and calculated currents. If that error increases in time, that also provides us information. AnomAlert is very suitable and best used actually for systems which are difficult to access, like submersible pumps under the water, borehole pumps, and similar equipment that are difficult to reach. As a matter of fact, AnomAlert is probably the only condition monitoring equipment available for those applications. For applications where the systems are in a hazardous area, difficult to reach, like in nuclear installations or in other places, there AnomAlert would be an excellent and maybe the only solution. The typical applications that we would have is hazardous locations, dangerous to, difficult to access, high criticality motors. Air handling units is one of the most implementations we have, as well as submersible pumps and pumps. Systems with cyclic duty, cryogenic motors and pumps, fin fans, and submerged remote offshore systems could be other examples. Once again, I would like to indicate that one of our objectives, actually the most significant objective we have, is to improve the effectiveness of the maintenance team. The maintenance team are always busy, as we have seen in industry. They never have time to meet all the demands that they are receiving. Hence, they can only look at a certain portion of very highly critical equipment. With AnomAlert, it will be possible to expand their focus not only to very critical equipment, but other medium criticality and low criticality equipment, and this could eliminate the downtime significantly, while also improving their effectiveness. They also will be able to do their work more effectively. Again, along those lines, the applications could be, as I mentioned earlier, highly critical, medium critical, and lower criticality equipment, where AnomAlert would provide information that may be used by an average engineer or technician rather than data to analyze. And for highly critical as well as complicated equipment, AnomAlert can also be used for the purpose of doing condition monitoring when needed. And at that time, not only the information provided by AnomAlert, especially, it also provides additional data. Those data, as well as vibration and any other diagnostic equipment you may have, you would be able to use them. But basically, we expect that by use of AnomAlert, you will be able to expand your coverage of equipment for condition monitoring, as well as you will be able to get reliable and accurate information and improve and increase your effectiveness. I am going to stop here. I want to thank you for listening me and giving me this opportunity to explain you our technology.